that is it for that section. The next section is even and odd functions. This is section 2.4. With even and odd functions, if you mastered the symmetry, the y-axis, the x-axis, and the origin, you'll do fine with this. If you didn't, you'll have more practice doing it right now. So, even functions are symmetric to the y-axis. That's the only important piece of information you need. Odd functions are symmetric to the origin. So some people are going to go, well, what if it's symmetric to the x-axis? Remember, if it is symmetric to the x-axis, it won't be a function. Because if it's symmetric to the axis, that means it has to fold over the x-axis. And remember, that doesn't pass the vertical line test. So it will never be symmetric to the x-axis if it is even or odd. Even and odd functions have to be a function in order to be even or odd. Symmetric doesn't necessarily have to be a function. It just has to be a graph that will fold over one of the axes. So, let's see what we have here. Alright, is f increasing on the interval -8 to -2? This is an interval. This is not an ordered pair. So they want to know from x equals -2, or -8, excuse me, from x equals -8, which is right here, to x equals -2, which is right there, does your graph go up? Does the blue line go up? And you should say yes. For f is increasing on the interval 2 to 10. So 2 is our x value. To 10 is the graph increasing. Well, yeah, right here, but not the whole time. So you're going to say no. So this is asking, what are the intervals in which it is increasing? So let's split it apart. Let's go from peak to valley and valley to peaks. So right here comes to our first valley. That is decreasing. Right here, we already said, is increasing. So we're going to increase from -8 to -2. Then we go to our next valley. So -2 to 0 is not increasing, that's decreasing. Then we go from 0 to our next peak of 2, and that is increasing. So 0 to 2. These are intervals, not ordered pairs. From 2 to 1, 2, 3, 4, 5, we are decreasing. So from 5 on, notice there's an arrow, so that means 5 to infinity. We are increasing. Yay, yo, yo. They want to know if there's a local maximum at 2. If yes, you're supposed to state what it is. So if we look at x equals 2, is there a high spot? And your answer is yes, right there. So yes, and you want to list the ordered pair of 2, 10. So a local maximum is your hill or your valleys. And another thing that it is this key. This is what people miss every year, so I hope you're listening. If you have a closed interval, so if these were not arrows, they were dots, those would also be maximums. If those are closed, they would also be maximums. Remember that. All 4 of these spots would be maximums if those are closed. Right now, since they aren't closed, these 2 are only maximums. These 3 are our minimums. So, keep that in mind. List the numbers at which has a local maximum. So we're supposed to list all of them. And so I just told you what they were. -2, 6, and 2, 10. Remember, if these were closed, you would also have to pick those. So, find the intercepts. We can do that. Write them down. State the domain. You can do that. Range. Do it. Intervals of where your graph goes up. Intervals of where your graph decreases. Intervals where it's constant, so that means it's a flat line. And tell me if it's even, odd, or neither. So, let's do the intercepts. Pause the video, do that stuff what you can, and then replay it. See if you got the same things. So intercepts, I'm going to say, are -2, 0, 0, 3, and 2, 0. So I just kind of went down my line. The domain, since these are closed, is going from -4 to 4 with brackets. Your range, so that's our y values, go from 0, that's our lowest point, that's our y value there, to our highest point, which is 3. So 0 to 3. Brackets on those. Your intervals of increase. So we increase, these are x values only. Intervals are always just x values. So we increase from here to here, which is -2 to 0, x values. Then we increase on the end from 2 to 4. We decrease from here, so -4 to -2, and we decrease here 0 to 2. Please come with questions about this because intervals of increase and decrease are always confusing, so please come with a lot of questions about that. All right, constant. There is no place where we're flat, so there's no constant. Is it even, odd, or neither? Even is symmetric to the y-axis, so if I would fold this, would it be symmetric to the y-axis? And your answer is yes, so it is even. If it's even, it can't be odd, and it can't be neither. It's one or the other. So see if you can do this one on your own. Same stuff, different graph. Pause it, start it. So that's pi, that's negative pi. So we got negative pi 0, 0, 0, and pi 0. We have a domain of negative pi to pi, and those should be brackets because those are closed. That's our domain. Our range, our lowest spot is at -1, and our highest spot is at +1. And those are dots, so it's closed. We increase from -1 to 1, and we decrease from negative pi, and that's not -1, is it? No, because that's not 2. So it's pi over 2, excuse me. So negative pi over 2 to pi over 2. You can't read that. So negative pi over 2 to pi over 2. Those weren't ones. All right, so we aren't increasing from -1 to 1. We are increasing from negative pi over 2 to positive pi over 2. And those, dang it, my range was right. I'm screwing this video up, aren't I? So the range was -1, 1, because those are 1, 2, 3. And these are pi, so that's why the increasing changed. All right, so we are decreasing from negative pi to negative pi over 2. And then we decrease here at the end from positive pi over 2 to pi. Huh. We aren't constant because the graph isn't flat. Even, it folds on the y-axis. This would not fold on the y-axis. Odd, it flips about the origin. So if we flip this upside down, you do get the same graph. So it would be origin. Yay, go you. Which is odd. So now we need to determine algebraically, this is the last thing, if these are even, odd, or neither. So to determine algebraically if it's even, you check for y-axis. If it's odd, we're going to check for origin. If it's not one of those, then that means it's neither. So to check for y-axis, so we're going to write this as y equals 4x cubed. To check for y-axis, you put in negative x. So we got y equals 4 times negative x cubed. If you simplify, like we did the other day, you get negative 4x cubed. That is not the same, so sad face, not even. For odd, we're going to test for origin, so we're going to put in negative y and negative x. We're going to simplify, so we get negative y equals negative 4x cubed. And I'm going through this kind of fast because you should have learned that last time. So you need to pause the video. We want to multiply by -1, and you get the same thing that you started with. So it's origin, which means it is odd. See if you can test this one on your own for even, odd, or neither. So for even, we put in negative x. You get y equals negative x squared becomes positive x. We still have that negative on the 3. And that is the same, so it is even. Do you have to test for the others? If you want to make sure you did it right, sure. All right, so even, we put in negative x. The absolute value of negative x would simplify to just positive x. However, this negative x would not simplify, so it's not even. Put in negative y and negative x. Then absolute value does simplify again. Since we have a negative y, we could try and multiply by negative 1. That changes the y to a positive, that x to a positive, and then absolute value out in front to a negative. So that's not the same either, so it's not odd. So that means it is neither. There you go, you. And that is it for this discussion. Please come with lots of questions for next time.